deals with quadratics, and a quadratic equation is an equation where the highest exponent is an x squared. Okay, so if you have an x squared and that's your highest exponent, then you have a quadratic equation. So if you hear me say the word quadratic, I'm just talking about an equation that has an x squared in it. The graph of all quadratics is called a parabola. Say that word, parabola. Beautiful. Okay, so a parabola is a U-shaped graph. It'll either be a U, which looks like a valley, or it'll be upside down U, which looks like a hill, right? Hills and valleys. So the lowest or the highest point, so if we have a U shape, we have a lowest point. And if we have an upside down U shape, we have a highest point. Well, that's called the vertex. And actually, there's a center line, vertical line that goes down the center of a parabola called the axis of symmetry. Now, what does that word symmetry mean? What does that mean? Exactly the same on both sides. So we have a vertical line that's called the axis of symmetry, so that if I fold my parabola in half through the axis of symmetry, both sides mirror each other. They look exactly the same. Every parabola has an axis of symmetry, and every parabola looks the same on both sides. Okay? So axis of symmetry. So we're going to talk lots about those in section 10.2. So we're going to start by just practicing graphing parabolas. And we're going to graph parabolas first by making a table. So remember, when we have a table, we have x and y values, and we put them together and we get ordered pairs, right? So we're going to get our ordered pairs, and then we're going to graph our points, and we're going to graph our U-shaped parabola. So this one is y equals x squared. Now this is a special parabola. It is the parent function. And I think we might have talked about parent functions when we talked about lines just a little bit. The parent function is the most basic one. It's what every other one is modeled after. So this one's quadratic, so this is going to be the parent quadratic function, y equals x squared. So we're going to fill in our table. So how do you think we're going to get our y values? Plug in the x's, right? So the first one, I'm going to say negative 2 squared equals what? And the calculator will lie to you and tell you it's negative 4, but it's not. What's negative 2 squared? Positive 4. So put a 4 there. And then I do negative 1 squared. What's negative 1 squared? 1. What's 0 squared? 0. Sorry. And then I do, what's 1 squared? 1. And what's 2 squared? So what do I notice about these points? They're all positive. What else? They repeat, right? So that means this right here is the center of my parabola, also called the vertex. And then they start repeating each other after that point, don't they? Right? So y'all want to know something helpful about our tables? All you have to do is do the first 3, and then you can start repeating without doing the math. Because all parabolas are symmetric, so they're going to be the same on both sides. They're going to have repeating of y values. So we're going to graph those 5 points. Like we said, all of our y values are positive, so we really don't have to show anything in the bottom 2 quadrants. Go left 2 up 4. Left 1 up 1. 0, 0. And then 0, 1. And then right 2 up 4. And notice that you have points that match each other across from each other. Right? So then you make a U. I know some of these look like V's, but you need to do your best you can to round the bottom out and make it a U shape, not a V shape. So that is the parent quadratic function. It's the most basic quadratic parabola that we're going to see, y equals x squared. So all other parabolas have similarities of this parabola. They're going to be similar. They're going to have axis of symmetry, the vertex, and all that good stuff. They're going to make a U shape. Like lines, parabolas go on forever. So what do we show on our graph to show that it goes to infinity? Arrows. So make sure you put arrows on your parabolas. It's technically not correct if you don't. So there's your first one. I didn't get that all erased, apparently. All right, so this one's a little different. It says y equals 2x squared. So you're going to pick your x's. I want you to always use -2, -1, 0, 1, and 2 for your x's for these. And then we're going to start plugging in our x values to get our y values. So I'm going to start with 2 times -2 squared. Now, y'all, order of operations, what comes first, multiplying or raising to a power? Raising to a power. So make sure you do the square part first. So what is -2 squared? 4, and 4 times 2 is 8. You do it like this. So make sure you do your exponent before you multiply. So then I'm going to do 2 times -1 squared. What's -1 squared? And 2 times 1 equals 2. Then I have 2 times 0 squared. What is that going to equal? And guess what's going to happen after that? So this one is going to repeat here, and this one's going to repeat here, right? So this is going to be a 2, and this one's going to be an 8. If you don't believe me, check it. 2 squared is 4. 4 times 2 is 8. 2 times 1 is... Or 1 squared is 1. 2 times 1 is 2. So there's my 5 points for that one. Now this one goes all the way up to 8. So it's going to have to go kind of tall on your y values. Do what? Yeah, because it's going to be more slim, I guess you would say, more narrow. So -2, 8. Left 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then left 1 up 2, 0, 0. And you're right, it's going to be really skinny. So you just got to be very careful and try to round it the best you can at the bottom. Oh, look how crooked I went right there. Oh, well. Arrows on top. So this one's kind of a stretched out version of the parent graph, is it not? So what makes it stretch out and get kind of longer is multiplying the x squared by a number bigger than 1. So if we multiply our x squared times a number bigger than 1, it's going to make the graph more narrow. It's going to kind of stretch it up. Does that make sense? So a number bigger than 1 times your x squared makes it more narrow. Now we got a fraction. And we're not going to cry about it. Fractions are our friends. We should be glad to see our friends. Well, they're my friends. All right, so let's plug in our numbers. I got -1/4 times -2 squared. Well, what's -2 squared? Exponent first. What's -2 squared? So what's -1/4 times 4? -1. That's not so bad, is it? So then I have -1/4 times -1 squared. What's -1 squared? And -1/4 times 1 is -1/4. So that's this one. Then I plug in 0. What's that going to equal? That's going to equal what? 0. And then they start repeating. So that one's going to be a -1/4 and this one's going to be a -1. So you only have to work 3 of them out and the 0 one's easy, right? Because, you know, this one's going to match to this one and this one's going to match to this one. All right? Then you graph those 5 points. Now, what do you notice about these 5 points? They're all negatives. What else? They're what? Yes, it's going to be upside down because you've probably graphed it ahead of me. So I go left 2 down 1 and then left 1 down a 4. That's really little. And then 0, 0, and then they match up on the other side. Now this is going to be an upside down U-shaped parabola. Mine don't look exactly the same on both sides, but you get the picture. So let's think about what made it turn upside down and what made it really wide. You see how it's wide? It's upside down and it's kind of wide, really, compared to the last one we did. So the fraction, we should say number smaller than 1. With the x squared makes the parabola wide. A number less than 1 with the x squared makes your parabola wider. So greater than 1 made it more narrow. Smaller than 1 makes it wider. Does that make sense? All right. And what do you think turned it upside down? The negative. A negative sign, the x squared, makes parabola upside down. So anytime you see a negative in front of your x squared, you're going to have an upside down parabola. If it's positive, it's going to be a U shape like regular. If it's negative with the x squared, it's going to make it upside down. If it's a whole number in front, or a number bigger than 1 in front of your x squared, it's going to stretch it up, make it more narrow. If it's a fraction or a number that's smaller than 1 in front of your x squared, it's going to make it more wide. So fractions make you fat. There you go. Like my pizza fractions did last night. Okay. So now let's see what happens if we add or subtract with our x squared. So we're going to plug in our -2, -1, 0, 1, and 2. This time into the equation y equals x squared plus 2. So first we're going to do -2 squared plus 2. What comes first, the exponent or addition? Exponent, bless you. What is -2 squared? And 4 plus 2 equals 6. So that one's a 6 and that one's a 6, right? Then I do -1 squared plus 2. What's -1 squared? And what's 1 plus 2? So this one's a 3 and this one's a 3. And then I do 0 squared plus 2. What's 0 squared? And what's 0 plus 2? 2. So this time is my first time my vertex is not at the origin, isn't it? Okay, my vertex is not at the origin this time. It's 0, 2. So let's graph those. All my y's are positive. So -2 up 6. 1, 2, 3, 4, 5, 6. Left 1 up 3. 0, 2. 3, 6. And then make a U. I missed my point down there. That's a little better. Arrows on it. And you're done. Compare this one to your parent function. How is this one different from the very first example we did? Because it's the most basic one. That parent function is the most basic parabola. How is this parabola different? It's not on the origin. Where is it? It's up 2, right? The vertex is shifted up 2. I could have told you before I graphed it that was going to happen. You know how? Because it says You're graphing y equals x squared. Well, that's the parent function, isn't it? That's the parent one. And then I shifted up 2. So if I have plus 2, it's going to go up 2. The vertex will. So what do you think is going to happen if I have a minus a number? It's going to go down however many spaces. Okay? So a plus and a minus after your x squared tells you it's a vertical shift. They call it the vertical shift. You either shift it up if it's a plus or down if it's a negative. Does that make sense? Or a minus. All right. This one's going to have all kinds of fun. Let's make some predictions, though. Y'all are really smart. You really are smarter than me. Say it again. It's going to be wide. What's going to make it wide? The fraction, and then it's going to be what? The vertex will be shifted down from the origin 4 times, right? Something else I want y'all to tell me. Do you think this is going to be a U shape or an upside down U shape? In front of the x squared, is it positive or negative? It's positive in front of x squared, so that means it's going to be a U. So it's just going to be a wide U, like he says, but it's going to go down from the origin. So let's graph it and make sure our prediction was correct. So I say 1/2 times -2 squared minus 4. So order of operations, what do I do first? The exponent. So I say 1/2 times -2 squared is 4, right? What's a half of 4? And what's 2 minus 4? So this one's -2, and also the last one is -2. Any questions about that one? Then I do the same thing with -1. Exponent comes first. What's -1 squared? 1. What's a half times 1? What's a half minus 4? -3.5, right? And yeah, it's okay to get mixed numbers when you're doing graphs, because actually it's a little easier with mixed numbers and graphs than it is with improper. It's one of the rare times I'm going to tell you, make it a mixed number. I like impropers. Algebra usually lends itself better to impropers, but not when you're graphing. What's 0 squared? What's 0 times a half? 0. And what is 0 minus 4? -4. Is that like a squeaky wheel in the hallway? Okay. I didn't know what that sound was. So there's my 3 points. Or my 5 points. I don't know why I said 3. I worked 3 of them. These are all negative y values, so we're going to go below the x-axis here. Left 2 down 2. Left 1 down 3.5. 0, -4, and then they repeat. Graphing the last 2 are easy because they're just repeating the space. You're just looking straight across from where you already have a point. Mine's really crooked, but try to round it. All right, so question, were our predictions correct? Are we wide? Or wider than the parent function anyway? Are we shifted down 4 from the origin? Are we a regular U shape, not upside down? Yeah. So if you have a multiple choice question, could you, without even doing this, could you have looked at your 4 choices and saw which one matched the graph? More than likely you could have. Yeah. All right, y'all tell me what you think is going to happen with this one. Upside down, fat or skinny? How do you know it's skinny? Right, there's a number bigger than 1 with the x squared. Is it going to be on the origin? Where at from the origin is the vertex going to be? Up 3. So it's going to be upside down, skinny, and up. The vertex will be up at 0, 3. That's our predictions. That should be what happens. So -2 times -2 squared plus 3. What's -2 squared? 4. So negative 2 times 4 plus 3. What's negative 2 times 4? And what's negative 8 plus 3? Negative 5. So this one's negative 5, and this one's negative 5. Then I plug in a 1 or a negative 1. What's negative 1 squared, Tyler? Yep. What's negative 2 times 1, y'all? What's negative 2 plus 3, y'all? 1. So that's 1, that's 1. And then I do my 0. What's that going to be? 3, because all that makes 0, and 0 plus 3 is 3. So any questions on my table? All right, then we graph those 5 points. So left 2 down 5. Left 1 up 1. 0 up 3. Really skinny. And then they match up. Yeah, these skinny ones are hard to not make them look like a V. So were we right? Upside down skinny and up 3? So that's just one way we can check and make sure our graph's right. You know, the equation should tell us what's going to happen to it. Any questions on this parabola? All right, I want you guys to graph this parabola. Fat or skinny? U shape or upside down? Is it on the origin? Where's the vertex going to be at? Yep. Okay. It's fun to graph something besides straight lines, isn't it? All right. So 2 times negative 2 squared minus 6. What's negative 2 squared? 4 times 2 is 8, and 8 minus 6, did y'all get 2 for that one? And then you did 2 times negative 1 squared minus 6. What's negative 1 squared? 1 times 2 is 2 minus 6 is negative 4. So did y'all get negative 4 for those? And then 2 times 0 squared is 0 minus 6 is negative 6. Y'all get that table? All right. And then you drew your graph. Lots of negatives. Left 2 up 2. Left 1 down 4. 1, 2, 3, 4, 6. Drew's looking like mine. Tall and skinny. I always feel a little dip right there. I don't know why I do that. See, I did it again. Oh well. Arrows. Raise your hand if yours looks like mine or prettier. It can't look much worse. Just try to hit my points and make it a U, okay? And make sure you put arrows on it, and I'm good. All right, so that's the end of this lesson, and I do want to go ahead and do a little bit in section 10.2 to get us started for tomorrow. So, if you want to, you don't need graph paper for the part we're going to do. Just notebook paper will be fine. Okay, we're going to stop. We're just going to do 2 examples. And this will kind of lead us into tomorrow's lesson a little bit. Just because we have extra time today, so that way we're not scrambling tomorrow. Because this lesson is actually a long section, so it'll kind of help us if we already get this part out of the way. So here's a formula you need to memorize. Okay, it's for finding the axis of symmetry of a parabola. Now the axis of symmetry, remember, is the vertical line that goes through the center of the parabola. So it's an imaginary line. It's really not part of the parabola, but it's a line that exists through the middle of the line. It goes through the vertex. Okay, the very center of your parabola. And we learned back in chapter 4 that x equals a number is a vertical line, right? Anytime we're graphing x equals a number, it's a vertical line. So we're finding what vertical line is our axis of symmetry for our quadratic. Okay? So we're finding the vertical line that is the center of the parabola when we're finding the axis of symmetry. Okay? And the formula is negative b over 2a. Well, we might be wondering what a and b are. And that comes from this equation right here. This is called the standard form of an equation of a line. Or an equation of a parabola. I'm sorry, a quadratic. Standard form of a quadratic is ax squared plus bx plus c. You'll be seeing that a lot throughout this chapter. Ax squared plus bx plus c is the standard form of a quadratic equation. A, b, and c are just numbers, your coefficients. Sometimes we call c the constant term because it doesn't have a variable. Okay? So your a term is your term with the x squared. It's the term in front of the x squared. It's your leading coefficient, if you will. Okay? And the b term is the term in the middle with just the x. So the a term is with the x squared. The b term is with the x. Okay? So we want to find the axis of symmetry for this quadratic equation right here. Y equals negative 2x squared plus 12x minus 7. So I'm looking for the vertical line that goes through the center of this parabola. Now we're not going to graph this parabola yet. We're going to do that tomorrow from this form. From standard form, we're going to graph parabolas tomorrow. What we're going to do right now is just find the axis of symmetry And then I'm going to tell you how to get the vertex, which is the point of the center. So first, let's find the line that goes through the center of that parabola. We use the formula for the axis of symmetry. If you see me write AOS, that means axis of symmetry. Okay? So I'll just abbreviate that, and y'all can too. AOS is axis of symmetry. And what's the formula for the axis of symmetry? X equals what? Negative B over 2A. So before I even look at my equation, I'm going to put that negative on the top. So I want you to do the same thing. Before you even look for B, put your negative on the top so you don't forget it. What is your B term in that quadratic equation? 12 over 2 times, what's your A term? Negative 2. Y'all get that? This is A, this is B, this is C. You don't need the C. All right, then you're going to simplify this fraction. So negative 12 is just going to be negative 12 over, what's 2 times negative 2? Negative 4. And what is negative 12 divided by negative 4 simplify to be? Positive 3. And I'm not just going to say it's 3. I'm going to say x equals 3 because it's a vertical line. So I need to have x equals a number for it to be an equation of a vertical line. Okay. Now, so there is the y value. Let's say I have this parabola right here. So that's my x intercept, or not the x-intercept, I'm sorry. That's my axis of symmetry, which is the vertical line that goes through the center of the parabola. So if I fold along my axis of symmetry, both sides of my parabola mirror each other. All right? Well, the vertex is the point that's the middle of the parabola. And it will be either the highest point if it's a U or the lowest point, which is an upside down U. In this case, it's going to be upside down because I have a negative number in front of my x squared. Right? So I want to find what this point is. Well, that point is on the parabola, but it's also on the what? Axis of symmetry, right? So that means it's going to have the same x value as the axis of symmetry, right? What two things do I need to write an ordered pair? X and a y. So I know the x value is 3. How do you think I'm going to get the y value? Plug it in where? Into the quadratic. Yeah. So what you're going to do after you get your AOX, your axis of symmetry, to get your vertex, you're going to plug your AOS to the quadratic. What's a quadratic? The equation with the x squared in it. Right? So I'm going to erase this because it's really not to do with this graph. That was just to show you all parabolas in general. This graph, of course, is upside down. So we're going to take the original equation, which is this right here, and everywhere I see an x, I'm going to put in a 3 because that's what I got for my AOS. So y is going to equal negative 2 times 3 squared, 12 times 3 minus 7. And then I'm going to do my order of operations, which means what's going to happen first. The exponent comes first. So what is 3 squared? 9. So that's going to be negative 2 times 9 minus 7. And then I multiply. So that's going to be negative 18 plus 36, 97. And then you can just add and subtract from left to right. Negative 18 plus 36 is positive 18. And what's positive 18 minus 7? 11. So my y value is 11. So I stick it with my x value and make the ordered pair 3, 11. So your x value and your axis of symmetry should be the same number. And you just plug that in and you get your y value and make the ordered pair for your vertex. So this is my axis of symmetry, vertical line. This is my vertex. It's an ordered pair. Mm-mm. But we're not graphing. It's going to be an upside down graph shifted to the right 3 and up 11. Won't even fit on our calculator screen. Let's do another one. I'll highlight it because it's kind of jumbled up with my other stuff. We've got to find two things: the axis of symmetry and the vertex. Now, guys, is it even possible to find the vertex before you find the axis of symmetry? No, it's not. You've got to find the axis of symmetry to plug it in to get the vertex. And we have a formula for axis of symmetry. What is the formula? It's not y equals x equals negative b over 2a because it's a vertical line. That's why it's x equals. So I'm going to write my equal sign. I'm going to put my negative there. What's my b term this time? It's 12 again. Over 2 times, what's our a term this time? 3. Any questions about where I got b and a? Middle term is b, the leading term is a. Then we simplify that fraction. Negative 12 won't simplify yet. What's 2 times 3? And what's negative 12 divided by 6? Negative 2. So x equals negative 2 is our axis of symmetry. It's always x equals a number, not just a number. So any questions on how we got the axis of symmetry? So that's the vertical line that goes through the center of our parabola. Well, now we want to know the actual point on the parabola that's the center. So how do we get the y value to make an ordered pair? Plug the negative 2 in where? In the quadratic for all of what values? The x values. Good. So y equals 3 times negative 2 squared plus 12 times negative 2. And then you do your arithmetic, your order of operation. So what's negative 2 squared? 4. So that's 3 times 4, and then I'm just going to skip writing that down. So what is 3 times 4? 12. What is 12 times negative 2? And then minus 8. And then you can subtract across. 12 minus 24 is negative 12. What's negative 12 minus 8? So there's my y value. Y equals negative 20. So what's my ordered pair for my vertex now? And we're really glad we're not graphing that one, right? By hand. We're just practicing getting AOS and vertex. So that's how you get an AOS. That's how you're going to get a vertex. So for tomorrow's lesson, we're going to start right here at this point, and I'll just show you a little sneak peek. We're going to use the AOS and vertex to help us graph the parabola. Okay? So I just want to go ahead and get this practice part out of the way, the intro to axis symmetry and vertex. This will not be included on your homework, I don't think. I think you're just going to practice the graphing part from 10.1. So that is all for today. Have a nice one.